All righty then. Then welcome everybody. Thank you very much for joining today. Today we have awesome topic for you: accelerating your microservice development cycles from code to cloud. And this is very special because today we have an awesome guest. So I think let's start with some introductions. So hi, my name is Idan. I'm the developer advocate at Ozcode, and today we have a special guest. Ilia, please introduce yourself, who you are, and what are you do? What do you do at Cycode?
Hey everybody, my name is Ilia. I've been working in security-oriented companies for about a decade now. Started at Checkpoint as a developer and then a team lead, and moved to a startup called Fireglass, which was later acquired by Symantec. And from there, I started one of the first developers at Cycode, and recently became the technology lead in the company.
Thank you very much for this awesome introduction. As you can see, Ilia would have tons of knowledge and war story to tell us about microservices. And I think this is really the major topic for today, and basically how to move fast with microservices. And I think the first thing first is, what is microservices? And I really just want to start from the basics, so we would have know everybody what we're talking about today. And we've been talking a lot about microservices in this channel. And just to start, microservices, right? What I really like about this slide, it's not a way to simplify your system. It's basically you take all the logic that you have and just break it into smaller modules. And by that, you get all kind of benefits, but you also, there is some things that are basically trade-offs, right? I don't think that microservice is a silver bullet to fix all world problems, but they have some really, really good features that you get in microservices. So with that, I would actually like to ask you, Ilya, maybe give us like a lay of the land. When someone wants to try to think about Monolith and microservices, how they should approach it. What do you think the main thing that they should think when they start?
Yeah, so basically, I think if you ask the average developer now, what is the right approach between monolith and microservices, I think most of them will say that microservices are the way to go, and monolith is something that is right, it belongs to the past. But actually, I think the main thing here is really the trade-offs, right? You have the advantages and disadvantages in both approaches. And I think that as a developer, as a company that starts and want to think about their solution, you need to consider the different aspects. There you can speak about the differences, and like it's a topic for multiple webinars. But we've covered four main topics, so we can discuss about it in high level, I think, which is really scalability, deployment, the developer velocity, and the complexity. And we can dive in and talk about each one.
Yeah, I think that would be great because, like you said, this is a very complex subject, right? It's like comparing oranges to apples, right? It's not really simple, but what I really like about what you made us here today is really just the ability to, talk about it in high level, so you can understand if you go this route and to choose between monoliths and microservices, what you should do. So I think let's dive into the first trade-off: scalability vs deployment.
Okay, so let's talk about scalability, which is kind of straightforward here, because basically when we talk about scalability, we talk about how your solution handles load and really a lot of traffic, a lot of CPU or memory that it reaches. And basically, when you have a monolith, you don't really have a lot of choices, but to scale the entire solution, right? The entire monolith, whether it's by adding CPU or RAM, or whether it's by creating another EC2 instance or something like that really has the entire code base and the entire solution in it. And usually this is very expensive and inefficient because I think in most solutions you may have some bottlenecks that they do the heavy logic, that they really are, maybe they have a lot of IO, or maybe some complicated algorithm runs there. And it's usually not the entire solution and the entire system that is under load. So in the microservices approach, really you can extract the heavy logic into a specific service. And most of the solutions, whether it's Kubernetes or AWS load solutions, they're really straightforward, and you can really set the limits on when do you want to scale a specific microservice. And it's easier and it's cheaper. And if your solution really is going to have load issues, or it has those specific bottlenecks, then really in the microservices, the approach will be better.
Yeah, and it really sounds like, you're actually planning, right, to handle this scalability issue from the get-go. But I think it's go to the other side, right? That in order to have it, you actually need to think about deployment. Can you chat a little bit about that?
Yeah, so basically, if we think about deployment, which is also something that a new company or a startup really needs to think about from the start. In the monolith, it's kind of straightforward. Usually, you have some kind of tarball, or you just go to some server, just git pull all the code and run some script that starts the entire process, and it's very easy. Similarly, the upgrades are easy. You either download a new version, or you git pull your new version and just run it, and the upgrade is easy. And on the other end, the microservices, really, once you have different blocks that communicate one with another, then you need to think about the dependencies. You need to think about backward compatibility. What happens if you service A talks to service B in some kind of protocol? It uses specific entities, and now service A was upgraded to send a different message. You need to make sure that service B either is upgraded prior to service A and it knows the new format of the message, or basically be able to route your way between the two versions. Okay, so and similarly, usually you need some kind of automation, whether it's some kind of a CD provider that knows how to upgrade the services at the same time, or in some kind of order. So really the deployment of microservices is something a lot more complex in that way.
That is really interesting, because I don't think there is a lot of systems today, even if they're in Monolith, that are not communicated with other APIs or services, right? So the problem of dependencies and handling versions and things like that exist anywhere, right? But when you move to microservices, it's just staring in front of you, right? You really need to think real of how do you gonna approach it, right? And same thing with automation, I would even say, right?
Yeah. Usually in a monolith, right? When you upgrade, the entire code base is upgraded, and all the classes that communicate one another are, you get them for free in the same upgrade. So
exactly,
it's really easy, and you can really start fast with a monolith. And usually a lot of startups do due to that reason.
Yep. Just from curiosity, at Cycode, like, how long usually this process of getting everything up and running takes?
Well, it really depends on the CD, on the continuous deployment provider, but it also you start by really deploying all the microservices, and once you mature a bit, you add some logic that you only want to upgrade the services that actually was changed in the pull request, right, in the commit. You don't want to really restart all the services if you don't need it. So it really depends on the stage in our life cycle. we started by doing it all, and then now, for example, we will only deploy a service if the code inside that microservice was changed. So it really depends. If it's like an all-out deployment, it could take, I think, 10 minutes, maybe less. And if it's only a specific service, that it could be a matter of minutes or even less.
And that is so cool because in Monolith, right, when you upgrade, you either up or down, right? The entire thing is up or down. But with microservices, right, like you can actually only upgrade the specific service, right, that is being changed. So it's much more robust in that way. And I think it's actually a good segue to talk about developer velocity.
Right. So basically, developer velocity is something that is very, very important, I think, in the life of a startup. And this really decides how fast the developers will be able to add features, to fix bugs, or even maybe to prevent the bugs from happening in the first place. So this is really a metric that needs to be considered. And when you talk about microservices and the idea of microservices is having little blocks of logic that are encapsulated and have only their specific logic there. So you can have a specific team or work on only their microservices, and once they change something, it usually doesn't break the entire solution, right? So it's really easy in that way, and it's really the right approach. On the other end, in the monolith, you don't have any choice but to touch the entire code base. It's deployed together, and the code is usually like classes that call each other, class A calls class B. And it's a bit scarier to change something because you are not 100% sure that the flow that you are now modifying is really the class you are now modifying is only affected by your flow, the one that you now touch, right? You think of a specific flow, you change some code, but usually it could be used by another different flow that you really are not familiar with, especially when the monolith becomes really, really large. And it's easier to break things in a monolith. It usually requires the other developers' verification, people not from your team, if you have different teams, guys that are touched specific classes before, and also in that regard, the tests in microservices, because the code bases of the microservices are usually small and do only one thing, the tests are really short and concise, and in the monolith, it could be very, very complex.
Yeah, and it's really you can see it very clearly when you try to upgrade, like a common library, right? Because in the monolith, if you try to upgrade the common library, all the other services or business logics, let's call them, because it's not really services in the monolith, that use that library need to upgrade all at the same time, right? And usually there is one legacy services that cannot be upgraded, and that just cascading. Right. And the cool thing about microservices, right? You can upgrade this library in every services when it fits, right? You don't really have to have the same version of everything at the same time or upgrade everything at the same time. You can do a rolling upgrade, which is really, really cool. But I think with great power comes great responsibility. And I think let's talk about the other side, right? About the complexity.
Yes, so complexity is really a big word, but what I meant by complexity is really how you can think about the entire application, the entire solution, how it works, right? So in Monolith, usually you have some kind of main method or some kind of single entry point that then starts triggering the entire flow by calling one class and it calls the next. And when you debug such a process, it usually is kind of straightforward. You can add breakpoints. When you have something, the stack trace is really helpful because you can actually see the classes and the functions that were called really easily and you understand the flow. And when working with microservices, then you by default you added a layer of complexity by adding the communication, right? So
Yeah.
services are now starting to communicate one another. Usually, you will introduce some sort of queue that will make the communication even more complex by adding maybe async behavior to the entire flow. You may have processes that are outside of your solution, like lambdas or other processes, APIs that are really outside of your reach, and they are also part of the flow now. So basically, now that when you think about microservices, this is really the hard part, right? To be able to see a session or see a flow and be able to debug it entirely and to understand what happened first, what led to which scenario, which call, which REST API led to the other to another action. This is really where microservices are becoming complex, and this is something that you need to think about when you decide between monolith and microservices, because at least from our experience, to make this to make their visibility to make the flow visible took us a lot of effort and a lot of time, and you need strong tools to be able to see the entire traffic and to debug it properly.
Yeah, and I think this is really good segue to what I really want to talk about with you next. What I really like about this webinar, we're going to take it real, right? This is not going to be like philosophical discussions. We would really want to show you real examples from real world and give you actual tips that if you're thinking about moving from monolith to microservices, what can be done to basically accelerate, right? That accelerate the transition to microservices, if that's what you want. And also, when you are developing this microservices architecture, what are the good things that you can do to basically move faster? Yep. And with that, Ilia, I know that you prepare for us like 5 tips for successful microservice deployment. So let's take it away.
Yeah. So this is several tips from our experience here at Cycode. And basically, the thing that we found really helps is automating as much as possible. As a general, we in Cycode really believe that when you do something manually multiple times, it really is frustrating, and you need to think of some script or some automation tool that will help you as a developer achieve it faster and without the need to do it all over again and waste time. So the tip here is really creating some kind of template or some kind of skeleton service, as we call it, that once you want to create another service, you simply can derive from that service, run some script, give it a name, give it a folder, and it will basically create some service with all the dependencies, with the login mechanisms, with the middleware, with the Kafka topics and the configuration. And all you need to do basically is add your logic and you're done. So at the start, really, when you start working with microservices, really the creating a new service can be really frustrating, and you can spend a lot of time doing it. So I think once your organization, once you understand how you want your microservice to look like, which dependencies it needs, what are the basic stuff, then really add the base Docker image, add a skeleton service, and automate as much as possible. So that creating a new service will be easy. The architecture, this is something that was really, really helpful in our case. We've chosen to work in the event-driven architecture, and we're based on Kafka. Basically, it means that most of the services are receiving some kind of input, usually from Kafka, from a topic. They consume some kind of message. they do their logic, and then they output their the entity or the result that they created into a different topic as well. So what it does when you think about a new service, you can already think about, okay, I have some service that for example runs on code and runs on some text and outputs a detection. So now I can create a new service that consumes that detection and runs its own logic. And all you need to do basically is define that this new service consumes that topic, and you're good to go. Basically, you're already your new service is already plugged in and connected and can start working with some output that another service created. And if you define your architecture well enough, this could be really helpful, and features that you design you really start to think about them, about which topics I already have, which outputs I already have, and how I can consume them and work from it onwards.
It's really cool because it's really make your architecture extendable, right?
Yeah, exactly.
You just need to think about the events, and then you let other services add what they want to consume, or maybe even modify the current logic. And you can see it also with this, I think, pattern really propagate from microservices world into UI design, right? With Redux and event-driven UI development, right? So you can have a large team, each one working on different events, and then put them together.
Exactly.
That's awesome.
Yeah, and each service can, take you can have multiple services listen to the same topic. You can have one topic consume the same entity, but only use specific fields. It doesn't need all of the data, so it's very flexible, and it really accelerated our development. And I think it was one of the best decisions that we made early on. Regarding, I will touch the other 2 points. Development, basically, you need some kind of script, something easy that can spin up all of the services that you want to work with when developers work on the features locally. Usually it can be done either by a Docker Compose that holds the entire services, and basically running it will create the entire environment for you, and you can decide which services you want to use or you don't want to use when you're working on some sort of feature or a bug. And regarding the monitoring, I touched it earlier in the complexity point. Again, you need to be able to understand the flows and the sessions, how they run, who calls which service, triggers which service. And this is we will touch it in the demo as well. You need to be able to slice your data in a way that you understand that. And it is used with the tenant IDs in multi-tenant solutions, and in tracing or correlation IDs to better understand the entire flow.
That is awesome. Thank you very much, Ilia. I really like how you crystallize, what the things, you need to automate, right? To move faster.
Yeah.
And I really like the base image specifically, because that is such a great tip, because really put into code, how do you work? And then not let every microservices just be a complete different thing. There is like a uniformity, because that really helped with what you say at the end. How do you monitor how you monitor the system? Because at the end of the day is really how startup move fast. And I just want to touch a little bit about that, because I really like the McKinsey report that they actually try to put numbers into why developer velocity matters. And they actually do it in a very interesting year. They do it when COVID hit. And they ask tons of developers and companies to really rank what really affects developer velocity. There is all kinds of things, from culture to tools to management. There is tons of topics. I think they have like 46 different key factors to understand how developer velocity actually come to be. And then they actually correlate it to the profit. and to the market share of those companies. And you can see here that companies that actually have high developer velocity index actually outperform the entire market. So really think hard about your developer velocity. Is actually not become like a privilege anymore. It's actually become like a must to have, right? If you don't move fast, your competition will. And another very interesting finding from that report is that there is several things that are really help differentiate what those companies actually doing different, because they all probably have developers and they're probably all humans today, but the tools they're using actually make a really big difference. And that is really where we will actually dive, I think, right now, and actually get into this second trade-off, right? The developer velocity versus complexity. And I think Ilia really put it nicely. When microservices give you the ability to work on different area, limit the blast radius of every change, but you no longer have a single process that you can just debug, next step, next, right? You need something to really help you to overcome this complexity. And I think you guys all know where I'm going with that next, and that is the live debugger. And if you're not familiar with what the live debugger is, this is something extremely cool. It's basically allow you to debug your processes, but they no longer have to be local. They can actually be in staging, they can be in production, and you can get two things immediately. One thing, as you can see here in a small movie, and we will dive a little bit more into the UI itself in a bit, is the ability to capture every exception. And as you can see here in the code, you will actually get these notions of how every line actually was executed to really understand how those exceptions actually happen. Actually, before we go to the other feature, let's just stop here. Let's really dive into that thing itself. So let's refresh the page and let's get starting. So what you see here, we have a small, this is the demo example of not realistic example. Don't worry, Ilia will give us a real world demo in a bit, so stay tuned. So this is just when you will go and see what the demo itself, you will understand what we're looking at. So here you can see that there was several exceptions happen. And if we will go to debug one exception, you can actually see the exact line of code that actually throw the exception with how we actually get here. If this if statement is null and this was true, and you can also see all the local variables, and you can actually go up and see all the local variables from the web request till the exception has happened. And you can also start seeing these correlations. And you can see here that there is this, that is the main request that we are debugging, but it's also related to a different exception that happened in a different service. And so this is the exception part, right? If something bad happened, as Sim told you something crashed, well, you can see it. However, sometimes there is more soft issues, right? And those soft issues are not necessarily end up in an exception, but basically you really want to know what happened in that specific line. And that is where trace pointer come into play. And what trace point really allow you to do is to add a breakpoint to any line of code in your system. It doesn't matter if you debug it locally or it's in staging or in production. And just to go a little bit deeper on how that look like, then the trace point session here, as you can see, you can have many trace point sessions at the same time. So each developer can debug different microservices or different code without disturbing each other. And what you can actually see here, you see really nice code exploration. So you can actually go through every symbol in your code and see the code and just go and add a trace point in that specific location. So for example, I can just go and put a trace point and add some message, but I already did that. And I just want to point out this one. And as you can see here, you can have a very complex message, right? With any local variables here or every argument that was called for the functions. And you can even add conditions. So for example, in this would only call when this expression is smaller than this expression, right? So you can do a lot of cool things here today, and you can then record those events that happen in your system without deploying it. And I think with that, let's just move back to Ilia to really did that. Maybe give us a brief of what we're going to see. We've been talking for half an hour, but we never actually talk about what Cycode is doing. So if you can give us like a small brief of what we are about to see.
Yeah, so Cycode basically, we aim to protect the entire DevOps lifecycle from code to cloud, which means we integrate to the different developer stages, whether it code usage, commits, pull requests, and all the area of the source code management, to the build servers, to the image artifactories such as Docker Hub and JFrog and GCR, and later on to the cloud itself, where your code runs, the application where the application actually runs. And once we're integrated there, we can see we try to look at all the flows in a holistic manner. Basically, we can see a commit created by a member A that led to a build service in a Jenkins server. The commit contained a hard-coded secret, and later on it reached your GCP cloud, and it now resides on some Apache server, right? And we're able to really give you give a detection, not just you have a problem, but actually what happened and what led to that problem. And we really try to, you can see all the features that we currently support. We really try to do it as fast as possible, meaning that we can detect a secret that is added to a pull request. We look for the code in the internet to see if the code was leaked by mistake or not by mistake. And basically, we have a lot, once we have the integrations to the different parts of the DevOps pipeline, we can really supply meaningful detections.
Now I see why you guys really choose the microservices architecture. When you talk about like external API, you guys are swimming in it with just all the other services that you guys are correlating together to really give this nice holistic security overview. Is that would be correct that you guys are trying to move the security problem, I think they call it shift left, to the as quick as possible?
Yeah, exactly. So the shift left is really a term that was, I think, it's kind of new, but the idea is really to try and stop the issue as fast as possible, meaning that when some user tries to push his credentials in plain text to a repository, you don't want it later on to reach some cloud provider or a build provider where it can leak to the logs or where it can be accessed in some other way. So the shift left it basically means you try to do it as close to the developer as possible, meaning block it in the pull request, even block it as a Git hook, right? Maybe have a CLI that runs on the developer's machine and really doesn't allow him to commit sensitive code or stuff like that.
And that is so cool. So can we have a demo, please?
Yep, let's go.
Let's go.
Okay, so I'm going to share my screen. What we'll do here, I open the Ozcode Live Debugger, and you can see the breakpoints that I added. Basically, I'm going to debug a session that involves multiple microservices, right? So you can see here, I will start the recording, and I will show you the code itself, the feature itself, and then we can look at the different trace points. So basically, I have a repository. I will add my new file, some Terraform file. Okay, so as you can see, this file, it has two issues. The first issue that it tries to commit a plain secret, right, a password in plain text. And also it tries to create a Postgres server, an Azure Postgres server by Terraform, and it tries to define it when the SSL enforcement is disabled, which is bad practice. So we'll try to create some pull request. We will push the file and create the pull request. And basically what happens now, because we integrated this organization with Cycode, we're able to, we're triggered upon every GitHub event that happens. For example, a code was pushed, a pull request was opened, and now that the pull request was opened, we can look at the content. And as you can see, our bot saw the password here, and it says that we have found the password and severity high. You have a lot of actions that the developer itself himself can perform. And also we can see here the SSL enforcement enabled, and the detection says that it should be enabled and is currently disabled. Also, we can see that the two checks have failed, and you can't merge the pull request until you fix those issues. Okay, so this is basically the feature itself. We can also tell it's not only alerting on an issue. We can also, in specific detection, we can also try and fix it right now. So developer can say, okay, I understand, please let's fix it. Okay, so I can return in a comment and say Cycode fix this violation, and
that is so cool.
We'll see what happens. Now we can look on the trace points. So as you can see here, we have a tenant ID and correlation ID. Now, this specific organization was integrated to different tenants, right? And this is something that happens in production all the time. And I need to understand the specific flow that I'm debugging now, right? I want to see the flow that I just ran. So I know that my tenant is this one. So I can actually filter the tenant using its UID. And now I only have the logs, the trace points that triggered for this tenant. Now I'm looking at, this is the entry point of the entire flow. This is the service that is listening to the GitHub webhook. As you can see, we saw a push event, we saw a branch creation, and we saw a pull request. Now I know that my flow that I'm trying to debug is the pull request one, and I can see the correlation ID here. So I will filter by this correlation ID. And right now I have the entire flow, okay, that I wanted. And this is the entire flow that I wanted. This is the pull request. This is the two scans that were published. We can see one for the infra configuration and the other one is for the secrets, right? The entire locals are here. You can go through the locals and see what type it was, what the scan type, and you can see, go over each service and try to understand if we had some issue in this flow. If I'm trying to validate the flow, I can really go between the different trace points and try to understand, is this the output is this the input that I'm expecting? If I reached service A, or for example, this is the scan service, then I can see, okay, scan service works great. Let's see what happens in the infra configuration detector. Did it receive all the expected variables that I'm looking into? And then in at the end, this is the final step of the process. This is the GitHub connector, which sends the comment that we saw, and we can really see the actual comment being sent here to GitHub. So this is super easy by filtering out, by adding the tenant ID and the correlation ID to each flow. I can filter out and digest the data very, very fast, and it's very, very helpful. Okay. Another point that is really something that I think Ozcode really shines in is basically you can see the code here, right? This is the decompiled code of my service. I know many developers that are developers that work with microservices. One of the main issues that happens is which version is currently running on the microservice, right? I deployed it,
Yeah.
I deployed it. Is my fix inside? Is my fix, what's happening, right? And how many times did we waste by debugging something that really didn't have our version? And by having the decompiled code here, I can literally see what is the code that currently runs on a microservice and really understand, oh, this is not my code, so I won't really waste time. Maybe I had some issue in the CD pipeline, and I will start by fixing it, and only then I will start debugging. And this is something from our experience, right? Ozcode has helped us several times when our continuous delivery provider failed us and they didn't update the right version. And easily by seeing the code, we understood that, okay, don't expect things to work. The fix is not there yet. So this is also something that's very helpful.
Yeah. And I really think that is really awesome overview. Thank you very much, Ilya. And I also think, like we talk about backward compatibility, right? Sometimes it's very hard to debug a situation when you have two versions of this, or you have one version that's been upgraded and the other one is actually a little bit in the past, right? So you try to debug it and you don't have a single Git commit to debug, right? Because there is different things on your system. And by seeing the actual code there can really reduce those complexities.
Exactly. And just to end the demo here, as you see, once I added the comment, I can refresh the PR itself, and Cycode tells that, okay, I finished processing it, and you can see the commit by our bot that basically turned the false into true. Inside your pull request, right? You added a pull request, it had an issue, and the Cycode found it, offered a solution, and did it right here. And now you can see that the IAC status check now passes because really the alert is not relevant anymore because it was fixed.
That is really, really awesome demo. Thank you very, Ilya. And I really think that the features that we see here, man, you guys are doing magic because it's so cool. Talking about developer velocity, right? Those changes, to undo them, it could be very hard, right? Just the time spent then on doing retrospective of how that happened. Oh, that is really a lifesaver. So thank you very much for this awesome demo. And I think with that, what I would really want to do maybe is to really open the floor to people to ask questions. While we have Ilia here with his ton of knowledge on how to really make sure that you run fast with microservices. So please, you can use the Q&A, or you can just throw things on the chat, and we can go with that. Okay, so we have first question. Ozcode put some overhead on the performance. When we use Cycode along with Ozcode, what is the extra overhead that it puts as far as performance is concerned? Okay, so I think I would let Ilya start talking about the Cycode side of things, and then I will address the Ozcode side of things. And yeah, we choose by default two companies that their name actually sounds almost the same. So yeah, please, Ilya, go ahead and answer what type of overhead and performance impact you will see.
Actually, we monitored it for a bit because anytime you choose a solution that that taps in your code and change it a bit as of Ozcode or as any production debugger really does, it's kind of scary right at the first because really it's something that messes, that's something that touches your code. When we measured the code, the different with and without Ozcode, we didn't find any real differences. In the milliseconds, nothing that really made us think twice about using it and speeding up our debugging experience.
And I think let me dive a little bit. Why is that? And thank you very much for what I really like about working with Cycode is they really put your things to the test, right? So let's touch a little bit about it. I'm not sure if it was pretty quick, but there is this pause and play button here that you need to click when you start adding those trace points. And I think that is one of the major points here of why Ozcode is a very lightweight on your performance overall. The first thing here, when you add those trace points, nothing really happens on your services until you click this start recording button. And only then we would actually go and instrument in real time that specific line of code to create these trace points. And when you're done debugging, you can click stop. And that would actually undo all those changes and your code goes back to normal. And that is the same thing when we also talk about errors. So when you capture all the errors, and we have this really nice graphic to show you that, only when the exception happened the first time, we say, hey, that call stack generate an exception, and that's the first time that happened. Let's add instrumentation to that specific code path and that specific code path alone. So when that exception happen again, it will then undo. It will first capture the exception with all the locals that you see, and then it will actually undo all the instrumentation. So 99.999% of the time, your code is not instrumented at all, so you won't see any performance impact over at all. Even that, we had another feature when we have the agent itself monitor how much CPU and memory it consumes. And if you see that it's go over the 3% CPU threshold that can be configured, it would actually start shutting down instrumentation. So you can be, you can now be a little bit more safe and know that you will not see more than 3% performance impact on your system. Another questions. Sorry that I don't say your name, but I will just murder your names. So please forgive me about that. How easy to set up and integrate with Ozcode Live Debugger? I would say it's pretty easy. Specific in Cycode example, you guys are using Docker. So the way you integrate with Ozcode is basically add this few line of code into your Docker file and you're done. Like it's as that simple. And as you can see here, you can also use it.
Have a base image that all services inherit, it becomes even more easy.
Exactly. Like the first tip, right? Just use a really good base image so nobody need to worry about it. If you use some cloud services, Azure is a great example for that. There is all kind of cool way that you can just run the live debugger almost everywhere. So if it's running C#, you're good to go. Another question, is it possible to turn off live debugger to reduce performance impact when it's not needed? The answer is yes. Basically, don't throw exceptions. But no, just kidding about that. You can actually then go and we can talk about it a little bit. Actually, I can show you that from the documentation itself. The way all this magic works is by using the .NET Profiling API. We actually use that API to make those dynamic instrumentation in real time. And that also, that feature in the .NET Framework or .NET Core is only enabled when this environment variable exists, right? Core CLR enabled profiling equal 1. So if you really want to shut everything off, you can just make it 0 and nothing would ever happen, like it's never existed. Before we will actually continue, there is something that I would like to ask Ilia. I'm just can't get over the demo that you show. If you take Cycode, right, the DevOps cyberspace is it's a huge space. What makes Cycode special? Well, how do you guys differentiate with you and other companies?
Yeah, so there's a lot of other cloud security vendors out there. And I think that we differ in two main aspects. The first is really the shift left aspect that we talked about, because think about, let's say you integrate with some security cloud solution that is perfect, right? It finds all the misconfigurations and finds all the secrets and viruses and whatnot, and you integrate it with your production environment that usually contains hundreds of instances and entities, and you receive hundreds or thousands of detections, right? What are you going to do now? You need a ton of resources and time to go over the detections, and maybe it knows how to remediate itself, like we showed in the pull request. Maybe it doesn't, but it really is a big task to go over the detections. And what Cycode offers, as we saw, is basically doing it as fast as possible before the code reach the production environment, before the code reach the build servers. And even with our CLI, it can do it before it will reach the SCM itself, right? The code management. So this is, I think, one aspect that makes Cycode really strong. And the other one, if I can share my screen.
Go ahead.
Yeah, so here we can see all the integrations that Cycode support, right? So we can see all the major source controls, the build providers, the container registries that usually the build providers upload their created images, the cloud infrastructures, all the big names, and we have also alerting and issue tracking to easily open issues to the developers that they can solve. And basically, once you allow us to integrate with all the different providers that most of the companies use, right, we can provide a holistic way of looking at things. It's not only you have a secret here, you have a misconfiguration there. It's really how it happened, when it happened, right? What was the image that was deployed in your Kubernetes pod, and what was the build server that built it, and when, and what was really the commit on which branch and on which pull request, right? And to show that strength, I can show you the knowledge graph, right, which is now in beta.
Ooh.
But yeah, once you really have all this data integrated, once you allow us to integrate with the different providers, we can really run interesting correlation between them. So, for example, I will look for all the repositories, right, which are private, which are connected, associated with a container image that is public. So this is really a misconfiguration. You have a repository that is private and is only seen by your organization, but the output, what it uploads is really an image that everybody can download, right? So we can see here the repository name and the image name and where you have it, right? We integrated with Docker Hub, and therefore we can we saw it there, and it really the graph allows you to do whatever you want and really connect between different really all the entities that we have retrieved from different providers. You can use it, for example, to see all commits. For example, that the message doesn't contain, for example, some string. For example, we try to commit all our code with the prefix of CYC, which is also a Jira the Jira pattern. And then once you have the commit, you can say, okay, I want it only for the branches that are named dev, right? And from there, you can jump and see only for repositories that the name is Cycode, and you can continue doing that and slice and dice your data and really create policies that will alert you anytime that the thing that you defined here happened.
That is so cool. And I think this is very unique because you can actually create those queries across different stages of your pipeline, right? From the source control to then to the CI/CD and then to the actually deployment. That is really cool feature. Thank you very much for that. And I think we almost out of time. There is one. It is safe to decompile code, and you can see it in plain code. So yeah, that is actually a great question. I think it's safe to decompile code as this is basically the IL that is running. It's just a different way to view it, I would say. Now, in terms of security, the agent itself has several mechanisms that would actually protect you, specifically when you debug things in production. Like it will automatically redact sensitive information. We give you out of the box PII reduction rules. And also we can actually offer you an on-prem solution. So then both the server and the agents and your code never leave your network. So it really depends on the compliance that you're looking at. We can provide you this solution, I believe. And if not, I would be happy to chat with you. And I know also Ilia would be happy to chat with you if you guys have any questions. And with that, I think we would say thank you.